We will start very soon, sir.
Okay.
Good morning, Zabid Miadat.
Good morning, sir. How are you, sir?
Fine, fine.
Good morning. আমাকে শুনতে পায়?
Yes, sir. You are clear, sir.
Hello?
Yes, sir. You are loud and
Hello?
clear, sir.
Clear? Oh,
Yes, sir.
ঠিক আছে?
Yes, sir. Totally.
Okay.
Okay.
I'm ready.
Okay.
Okay. Thank you. Thank you.
Hello, good morning, sir.
Morning.
Good morning. Khosru.
Yes,
How are you,
Sarkar.
Sarkar?
Sir, hello.
Fine? Okay. But একেবারে completely white and gray hair. Huh?
Yes, sir.
Welcome to the International Conference on Meteorology and Climate Science 2020, Day 2. I am Javed Miandad, Research Assistant of Department of Meteorology, University of Dhaka, with you as an anchor. Now the technical session 5 on severe weather will start. This session will be chaired by Dr. Shamorendra Kormokar, Chairman of National Oceanographic and Maritime Institute, NOAMI. Former Director of Bangladesh Meteorological Department and SARC Meteorological Research Center. Co-chair of the session is Engineer Bidut Kumar Shaha, Superintending Engineer, Processing and Flood Forecasting Circle, Bangladesh Water Development Board. I would like to request Honorable Chair and Co-Chair to start and conduct the session. Before starting the session, I would like to request Session Chair and Co-Chair to evaluate all presenters according to the prescribed format and send us as soon as possible. Thank you all.
Should I start?
Yes, sir. Please, sir.
Should
Yes, sir. Please.
শোনা যাচ্ছে? Do you hear me?
Clear,
Yes,
sir.
sir.
But okay. So welcome everybody, and I must thank Mr. Bidut Shah. Perhaps we were introduced before once upon a time or two times in Bangladesh, and welcome everybody in the session. So I'm going to start the session, technical session 5. Practically we have about 5 papers. Each will be for 20 minutes. And out of 20 minutes, I think 15 minutes will be for presentation and 5 minutes will be for question and answer. Now you like
Yes,
question and
sir.
answer?
I think so.
End or just at the end of the end on paper 21, simulation of storm surge for cyclone Amphan using MRI storm surge model with GSM and ECMWF data. It will be presented by Mr. S.M. Kamrul Hassan. He is a senior meteorologist of Bangladesh Meteorological Department. So I request Kamrul to present.
Sir, can you see my slides? Hello. Yes, it is seeing.
Yes, sir. We can see.
Yes, okay. Okay, shall I start because some background noise is there? Yes, and now it is okay. Okay.
Yes, sir. It is fixed now. You can start.
Okay. Thank you all, and thank you, respected chair and co-chair. and welcome everybody, and a very good morning. So, topic is of my presentation is simulation of storm surge generated by cyclone Amphan using GSM and ECMWF data. Actually, this is the operational model of using in BMD. So, with me, Dr. Said Jamal Ahmed of Duet Gazipur is the co-author. There is okay. In Bay of Bengal, actually, one of the active basin where frequently cyclone occurred, and though comparatively less cyclone occurred in Bay of Bengal. In northern Indian Ocean, that is 5 to 6 cyclone occurred every year. But if you look at the casualties, it is very high. 80% of casualties occurred, global casualties occurred in this region, and that is mainly due to a storm surge generated by cyclone. And in this area, actually, the storm surge is very high due to some reason. One is long continental shelf, shallow bathymetry in North Bay of Bengal, and very complex geometry. That means complex and dynamic geometry in the coastal area of Bangladesh. And there is a long tidal surge, long tidal range of, between east and west coast of Bangladesh. And this is the region actually, and also the shape of the coast is convex shape. That means cone shaped coast. So storm surge is very high in this region. Actually, storm surge is abnormal rise of sea surface due to two things actually, pressure drop and wind stress. I'll show it in next slide. So mechanism of storm surge, there is two main thing. One is inverse barometric effect. That means for pressure drop, the sea surface is rises. So for every 1 hectopascal or 1 millibar of pressure drop, 1 centimeter surge occurred. And second one is actually main wind setup, and that wind setup, that means wind stress, wind giving pressure on the surface of the seawater, and it creates a surge also. And that is surge is proportional to wind stress, that means square of wind speed, and also horizontal.
Excuse me, sir. I think your presentation got freeze on first slide.
Sorry, I can't hear. Hello? 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 Yes.
Yes, sir. We
Can you see
hear.
me? See
Yes.
my presentation?
Yes, sir.
Yes, yes. It is operational storm surge model using in BMD like that at BMD.
Yes, sir.
Hello? Okay.
Yes.
Okay, actually, my last slide was the to think what is the mechanism of storm surge. One is inverse parametric effect, and second one is wind setup, as I uh, explained earlier. And next one is actually operational storm surge which are using in BMD. There is two storm surge model. One is IITD model from IIT Delhi, developed by Dr. Dubey, and it is fully parametric. Parametric means in this model, uh, some parameter is needed to give as input, like pressure drop, latitude, longitude, maximum winds, radius of maximum wind, like that. And second one is MRI storm surge model. Actually, it means Meteorological Research Institute storm surge model, developed at Japan. That means it is also a at Research Institute of Japan Meteorological Agency. That model is slightly different from the IITD model. It is parametric. That means it can also run using by giving some parameter, as well as it can be some model output can be used as the input of MRI storm surge model. So in this study, actually, I am using MRI model and use NWP model, not parametric. So how this model actually work? So there is two type of input. First parametric, that means tropical cyclone information. It is parametric. So that input is wind and pressure, wind field and pressure field. And actually, after giving pressure drop and maximum wind speed and radius of maximum wind, it calculate the it generate the pressure field and wind field, and with the bathymetry it calculate the storm surge. That is the parametric one. And the next one is actually NWP GPVs. That means uh, as first one, wind field and pressure field is generated after giving parametric information. But for NWP, actually NWP other model generated pressure field and wind field is uh, giving as the input of MRI model, and then it calculate the storm surge. So for my case, actually, first one is not included. So I am using the second one, like get ECMW data or GSM data, and then make some subset of ECMWF data. That means there is a lot of parameter in ECMWF data. But for running storm surge model, only wind field and pressure field is needed. So in this study, I make a subset. Only pressure field and wind field is separated from original file, and then give as the input of MRI storm surge model, and then storm surge is generated. You know, the cyclone Amphan is actually a lot of paper already presented in this workshop, and I think I need not to discuss everything. So cyclone Amphan was developed in the month of May. About 17 May actually, it over Southeast Bay, it generated as a cyclone, and then mostly it moved towards northeastwards, and then cross West Bengal Sundarban coast on 20th May, and then cross over Khulna Satkira region and over Bangladesh. So, but during landfall, before landfall, actually that cyclone is cyclone became weak. At that means it I think my presentation already again stuck. Okay, so it so as a weak as a very weak as a weak cyclone, it make landfalls. For running model, actually, this model is two-dimensional, and the latitude, longitude, Cartesian are aqua grid, and area is 0 to 46 degree north and 95 to 160 degree east. Grid resolution is about 3.7 kilometer. Time step is 8 seconds, and forecast hour is 48. Forcing is already I said that GSM and GPB, GSM GPB and ECMWF data, mainly wind and pressure field, and every day, that means 19th May 00 UTC it started, and process I am using grads, mainly grads and image magic, but GMT also can be used. So this is actually two storm surge, that means two model output. First, that means in the left side, it is generated by ECMWF data. And you can see that the red point is the landfall point, actual landfall point, and ECMWF shows that the cyclone crossed slightly west side of actual landfall point. But if you see the right one, that means the model run with GSM output, it shows that cyclone cross almost over the actual landfall position. So in this case, the storm surge is generated by two data set. One is in the left hand side, it is generated by ECMWF data, and the right side it is generated by GSM data. So in the left side, you can see that the storm surge is generated mostly in the West Bengal coast as the cyclone cross west side of the actual landfall point. But in the for the GSM data, it perfectly showing that the storm surge is generated West Bengal as well as Bangladesh coast, and there is negative surge left side of the that means left side of the cyclone track. So this is the 2 point, the time series of 2 point at 21.6 degree north and 88.7 degree 7 degree east, and its storm surge is about 3.5 meter. It is actually in West Bengal coast, and the right one is at 21.6 degree east and north and 89.3 degree east. It is actually near Sundarban coast, and it shows about 3 meter, and the right one, that means the our West Bengal coast, it is about 3.5 meter, which is almost as RSMC forecasted. So conclusion is my presentation is as MRI model predicted storm surge generated by cyclone Amphan very well, and simulated storm surge using both data set shows storm surge, but there is special variation as track predicted by ECMWF and GSM are different. ECMWF showing west side of the actual landfall point, but GSM shows almost over actual point. For both cases, simulated storm surge was maximum on the right side, and normally it happened, and the negative surge in the left side, it is also normally happened. Simulated surge with GSM data shows higher accuracy than that of ECMWF, as ECMWF showing west of the actual landfall point. Simulated storm surge was close to reported or forecasted surge. There is no surge gauge along Bangladesh coast. For that reason, actually, it is very difficult to validate the model output. We mostly depend on uh, media or other reported storm surge, but there is no surge gauge. As there is no surge gauge, so it is difficult to actually validate. MRI model is very potential for Bay of Bengal. Different GVV can be used as the input of that model, and ensemble also possible. That means we are now trying to use WRF output as the input of MRI storm surge model, and also there is 31 ensemble member is available in GFS data. So we are trying to use that 31 ensemble member to generate use that data in the MRI storm surge model. Actually, further experiment needed to for the tuning of the model. I am very thankful to Mr. Nadav Kohunu. Actually, he is the developer of that model, and BMD has a very good relation with Mr. Nadav, and we are actually BMD is now part of development of MRI storm surge model. Thank you. If anybody has any question, I can answer.
Thank you, Kamrul, for your nice presentation and showing the storm surge height of tropical cyclone Amphan. Now, I ask question,
Yes, sir.
one or two questions because the time I think already almost over, but two questions, please.
Sir, can I ask a question, sir?
Yes.
Sir, regarding the parametric model, is it based on some statistical equation? Are those model are data driven? And another one is it representative to compare the parametric model with the NWP model if anyone wants to work with the parametric model? Thank you, sir.
Yes, actually, for parametric model, no, there is no statistical thing there. Only thing is, if you need position of the cyclone, that means latitude or longitude of the center of the cyclone, then maximum wind speed, that means expected or predicted maximum wind speed, and radius of maximum wind, along with pressure drop. That fourth thing you need to give as the input of for parametric model. Nothing statistical equation or nothing there. So with that, actually it calculate pressure field and wind field, and then generate the storm surge with inverse that means barometric pressure and then wind stress. So that is one thing, and we already actually compared parametric run and NWP run already, and one student from Dhaka University this year already did that. I think, as I remember. My intention was only use NWP model. You know that NWP model, though NWP model actually always underestimate high wind speed, but recently the development of NWP is that means performance of NWP model is very good. So we are trying to use NWP models. Thank you.
Thank you, sir.
So, if there is no other question, can I go for the next paper?
Sir, may I ask a simple question, sir, please?
Okay, very short question.
A very short question. Actually, this is the maybe one of the model which is used for operational aspect in Bangladesh. Really, it is very fascinating. Thank you for excellent talk. Just my small query: how is the time delay of the to measure the storm surge height, and how it could be reducible? Thank you. Thank you very much.
Actually, as I am trying to run with NWPA output, that means GPP data. So it depends actually the atmospheric model. If atmospheric model is skill of atmospheric model is very high, that means correctly it predicts pressure and wind, as well as the accurate point of landfall and time of landfall, then that storm surge will be there will be no time delay at all. For that reason, actually, we are trying to use ensemble. We are going for ensemble run. Most of the advanced center already started ensemble run, so we are trying to do that. Thank you.
Thank you, Mr. Kamrul, for your nice presentation and the question answer. So, please try to make it more improvement and compare and validate the things. I think there was some rainbows in the Huron Point, but that is not maybe working because it was under BWDB. Mr. Bidut Kumar Shaha, he can speak on this matter because it was established in 1981, so far I can remember. Is it working now? Mr. Shah, do you know it about it?
Yeah.
Huron Point?
Yeah, actually, I don't have actual information, but I can. Okay, I will confirm it later on.
Okay. Thank you. Then our next presentation is ICMCS 22, paper number, simulation of high impact rainfall event of 26 to 27 September 2020 over Rangpur, Bangladesh, using WRF ARW model by Dr. M.N. Hassan, that means Nazmul Hassan, Department of Meteorology, University of Dhaka. And that I think is very interesting because this rainfall, I think, inundated the whole Rangpur division or Rangpur town. Please, Dr. Nazmul, please present your paper.
Can you hear me?
Yes.
Hello?
Yes, sir, we can hear
Yes.
you.
Yeah, and my presentation is okay?
Yeah.
Yes, sir. Welcome, everyone. Good day. And sir, I am very happy to have you as a chair in this session. And I am Dr. Mohammad Nazmul Hassan, and I am going to present this paper and welcome all participants to this presentation. The title of my presentation is Simulation of the High Impact Rainfall Events of 26-27 September 2020 over Rangpur, Bangladesh using WRF ARW model. I am going to first in the objective sessions. Actually, firstly, This study was done only using the WRF model. Later on, we decided to study the impact of the satellite radiation. So we have fixed two objectives. One is to document the causes and mechanism responsible for occurring such highly localized high impact rainfall events using WRF model. And second objective is to study the impact of the satellite radiance data on the simulation using 3D DA technique. So first of all, introduction. In introduction, we know that the Bangladesh is one of the disaster-prone country due to its geographical locations, and most of the natural disasters of the country have meteorological origin. And this high impact rainfall event causing flash flood is one of those disasters. So what is high impact rainfall events? Here we fixed the definition of the high impacts. The extreme rainfall events associated with flash floods, which causes severe impacts on the normal rhythm of life through damages of lives and properties, are designated as the high impact rainfall events. The main socio-economic sectors of the country are affected by such high impact rainfall events. That's why they study the causes and mechanism of such high impact rainfall events, as well as prediction of such impact events, poses to be an important and challenging task. Case descriptions during 26-27 September 2020, Rangpur, the northwest divisional city of Bangladesh, experienced a high impact rainfall events, and due to this event, a flash flood situation occurred over the Rangpur, and that inundated most of the area of the Rangpur city and marooned about 50,000 people. Uh, Within 24 hours, 26 and 27 September 2020, BMD recorded 449 millimeter of rainfall, out of which just in 12 hours, from 16 UTC to 16 UTC 26 September to 4 UTC 27 September, it recorded 433 millimeter rainfall. So if we see this figure, rain started from this time, and it stopped in this time. So the high impact rain over the Rangpur mainly occurred from here to here. And on 26 September, it received 267 millimeter rainfall, and in 27, it received 182 millimeter rainfall. This is the satellite image. In satellite image, we can see the signature of the deep convective clouds, especially on 00 UTC 27 September. But it starts developing, forming the cloud from 00 UTC 26 September, and with the progress of the time, it is intensifying, and rain mainly occurs from these times to up to these times. So during the rainfall time, convective clouds are observed in the satellite image clearly. For this study, double nesting domain are configured, having 9 and 3 kilometer resolutions. and physics and dynamics option. Actually, most of the physics and dynamic option are used, which are in default except WSM6. And in this study, we are not study the sensitivity of the scheme. Based on the previous study, these combinations of the schemes shows the better results, and we adopted these schemes for the study. We are not separately test the sensitivity for this case. Data used for the model run, NCEF GFS data were used 0.25 horizontal resolutions and 6 hourly temporal resolution. And for geography and land use, use USGS data. And for the data assimilation part, we use the AMSU among MHS data for this study. And to see the signature of the convective cloud, we use CIMSS Wisconsin University data. And to compare or validation purpose, we collected the data from Bangladesh Meteorological Department, and we use it accordingly. We run the model for 2 times. First, for the control run, we based on the 00 UTC 26 September, we run the model. And for the control run, and for the data assimilation run, we use the satellite data for the same time, 06 UTC 26 of September. And both control and data run were compared. Most of the analysis were done for the data assimilation run. So the results and discussion part. First of all, I give here the rainfall. Actually, I think the rainfall is the ultimate product of the NWP model. If the model can able to generate the rainfall over the location, then others parameter in association to produce the rain will be simulated accordingly. So this is the control panel, and this is the data simulation run. So in control run, the area, it simulated the rain over a larger area, and amount of rain was very less, 125 to 150 millimeter, and location also west to Rangpur. And in data simulation, it though it underestimated, but it simulated 250 to 275 millimeter rainfall, and position also almost Rangpur. It is 89.23 and 25.73. Here I want to compare the product, hourly product. So it is hourly rainfall from 13 UTC to 4 UTC. Here we can see that a convective cell which start developing before 1 UTC. It's with the progress of the time, it is matured and dissipated accordingly. And another cell start developing at 18 UTC, and with the progress of time, it is getting matured and dissipated. And after that, it is observed that so many cells are there, which may be the multi-cell types, and cells are continuously generated and dissipated. So this type of natures are observed from the hourly products. Next, humidity. In humidity, horizontal and vertical upper panel are horizontal profile and lower panel are vertical profile. The 00 UTC 27 September, the middle at that time the clouds and also rain cloud are more intense at that time. So I give this panel and to compare 3 hour ahead and 3 hour past given here for comparison purpose. And we see that the humidity from the vast area of Bay of Bengal converts towards Bangladesh and intrude towards the country in the order of 90 to 100%. In lower panel, vertical profile, it is observed that in all the slides, it more than 300 millimeter, 300 millibar level, it reaches in the order of 70 to 80% humidity. But in some cases, it also reached up to 100 millibar level in the order of 60 to 70%, and in some cases, it reaches up to 200 millibar level in the order of 80 to 90%. This is the sea level
Mr.
pressure.
Nazmul, you have 1 minute maximum.
Yeah, sir.
Please be quick.
In the wind chart, it is this is 950 millibar. It is 850 millibar. In 850 millibar chart, we see there is a trough here. This may be the part of the western disturbance, and due to this trough, a cyclonic circulation form over this area, and another extension of the low pressure. There is another cyclonic circulation over this area observed, and here is a anticyclonic circulation. So due to this cyclonic and anticyclonic circulation, winds over middle of the area was at a converts over Bangladesh, and due to this system, both type of wind meet over the area of Rangpur, and that uplifted. And this is the important features in the study. And in upper air, it is observed that the anticyclonic circulations. In wind shear, it is observed that 14 to 80 meter per second wind shear are over the study area, which may capable to generate the multi-cell thunderstorms. We study the W for vertical to see the vertical wind. Here it is from 89.23 is the longitudinal position of Rangpur. Here we observe that 5 to 6 meter per second over the area of the Rangpur. And this is the low-level vertical wind shear, which also shows the good result over the study area. And this is the cap. Upper panel is cap and lower panel kind. Here, surprisingly, the low cap observed over the area. We may think that this rainfall occurs due to converts the winds and for mechanically uplifting rather than dynamical. So I am in concluding session of the presentation. Actually, based on the only single case, general conclusion may not possible, but the study of this only for this case, we can say that the model captured the location of rainfall with minimum spatial and temporal error. Second one is model a simulated rainfall was fairly underestimated. Actually, the observed rainfall was higher than the model rainfall. It about 34% underestimated. And finally, we can say that these high impact rainfall events over Rangpur may be the results of the interactions between western disturbances and monsoonal systems. So this is all. Thank you all to hear this presentation. Thank you, sir. Sir, your microphone is off.
I'm sorry. Thank you very much, Dr. Nazrul.
Yes, sir.
Nazrul,
Welcome, sir.
Yeah, a very nice work. Actually, and heavy rainfall occurred on that day. So it was a nice presentation. Any question? One question I will allow because the time is already over. Please, from the audience.
Sir, can I have a query, sir?
Yes, yes.
Hello? Hello?
Yes, you can.
Okay. So, Dr. Nazrul, thank you for your nice presentation and you have been conducted a study with the recently happening, that is called high impact weather events, that is the rainfall event over northwestern part of Bangladesh. I found so many information you have collected. It's good. It's a good effort. But even though I have a query, whether you have taken into consideration whether any mass flux or moisture flux convergence was there or not during the happening of the event. Moisture flux convergence, whether you have tested for or not. That is my question.
Hello.
Can you ask the question again?
Noise is coming, and my
Yeah, noise is coming.
and my net is also disturbing. Sometimes it goes out. So I think there is a question from Dr. Abdul Mannan. Hello.
Can you ask me the question again? Due to noise, I can't
Dr.
guess.
Mannan. Maybe he is lost.
Okay, if he text, then I can answer it in text.
Please,
Yeah, in chat box.
Okay, thank you.
Okay. So our next presentation, we can go to the next presentation. Mannan, I think background noise is coming from your side. Please, can you control it?
I do.
So our next presentation, I think it is paper number 23, Understanding Thunderstorm Frequency in India, and the study on 20919, that is 2019 pre-monsoon severe weather events over Jamshedpur using WRF model. The presenter is Mr. Musaid PP, Department of Atmospheric Sciences, Central University of Rajasthan, India. So welcome, Mr. Musaid from Shudaz. Please.
Yeah, I'm going.
Please be strict with time.
Yeah,
because
sure.
we are already behind.
Okay. So am I audible? And my presentation is in your screen, right?
Yes.
Okay, thank
Yeah,
you,
yeah,
Dr.
yeah,
Kamlaka
we
sir,
can
and thank
hear.
you so much for giving me this opportunity. I'll start quickly. So this is actually, my name is Musaid and I'm working as a research associate in private sector, R&D. And this was a study which I've worked as part of my post-graduation in Central University of Rajasthan under Professor Somesh Das and Dr. Subbu Kumar Panda. So it titles as Understanding Thunderstorm Frequency in India, and a study on 2019 pre-monsoon severe weather events of Jamshedpur, which is a city in Jharkhand state of India, which is an eastern state. Before moving to this study, let me give you some hint of the background studies. Like, as you can see in the map, India is having a wide varieties of extreme severe weather events. You can see each state is having a very different weather events. It's basically because of its geographical positioning in the globe. So basically, we have a very wide varieties of severe weather events. So the top map showing is actually 2019 severe weather events. And the one graph is also shown in below. This is actually a study from Mahapatra et al. 2018. It is showing the death rate caused by these severe weather events. So as you can see, only one graph is going up. That is exactly the thunderstorm and lightning. So over the years, everything, cold wave, extreme precipitation, flood events, and even heat wave cause death are coming down. That we human people or the saving society can control this death rate. But this is not the case of thunderstorms. So thunderstorm is seeking some very attention from our side. So my objective of this study is basically the study is having two parts. One is understanding and examining the climatology of thunderstorm occurrences over India. Another part is I've gone through three different cases. One is a thunderstorm and a gusty wind or even. Another one is a thunder squall and um, thunder squall event, and third one is a thunderstorm and lightning event. So as we know, the thunderstorm is always is associated with these kind of weather phenomena. So I've taken three cases, and so we'll have a three case studies and also the climatological analysis as well. Moving ahead, this is my domain. So as you can see, it's eastern part of India. So for my model, I have three domains in the ratio of 9 kilometers, 3 kilometers, and 1 kilometers. And as I mentioned, the first two studies will be focused on the inner domain, that is 1 kilometer domain. And the third case, that is thunderstorm and lightning, is analyzed or is studied over the entire state, that is 3 kilometer. That is the second domain. And obviously I've used this Tyagi sir 2017, I mean 2007 Tyagi sir climatology. Also we have a lack of data, I mean database in case of thunderstorm. It is a huge data set. Like as we all know, thunderstorm is having a very large number. So the, the observational part of thunderstorm and database of thunderstorm is very rare. So basically, many of the studies are focused upon the LIS data set, that is lightning data set. So we will look at both these studies. Like we have a Tyagi sir observational climatology of thunderstorm events, and we have a lightning data set which is used for understanding and used for thunderstorm studies. So we will compare these two climatologies over India. Also, we have IITM lightning observation data set for 2000 pre-monsoon season as well. So we'll look into that as well. Coming to the this case studies, I've used IMD grid data set for comparison, and the MOSTAG INSAT 3D satellite observation is also used. ERA 5 and NSUP, I'm sorry, NSUP FNL data is also used. all the observations, all the case events are basically upon the observations from Jamshedpur. Jamshedpur is marked over the third domain. You can see a red point. So all the events are as per observed on Jamshedpur only. So moving ahead, as I mentioned, on the right side, you can see the LIS lightning database, and accordingly it's climatology. On left side, it is a climatology of thunderstorm by Tyagi sir. So basically in India, we have three hotspots. One is over the southern part, and another one is eastern part, and another one is northern part. So this is also can be seen in this as well. Here you can see some red points. Also here is also we have some red points as well as in the northern part. So we have three hotspots in India. And what briefly saying, basically on an annual number, when we take the annual numbers, we can say rarely it matches when the total number of thunderstorm occurrences and the total event of flash, lightning flash events matches, and we can say LIS can be used for an annual studies. But when we come to the monthly studies, as you can see, these are animation over monthly images. So there are discrepancies, there are inconsistencies in the event of lightning event as per record of LIS when we compare to the observations of Tyagi sir thunderstorm climatology. So on a monthly basis, LIS is not that accurate to use for thunderstorm studies. So this is clearly showing why we are having this much of deaths, because the observation part of thunderstorms is not as much as developed when compared to the other heat wave or flood events or precipitation events as well as. So that is a Q curve analysis from this. So moving ahead, I've used this. This is actually, when we talk about the LIS, we have LIS is having two segments. One is TRMM LIS, which was aborted on 2015, and thereafter in 2017, another mission in the International Space Station, ISS, was started. So basically the LIS climatology is depend upon the TRMM LIS mission. So later on, for 2018 and 2019, I have analyzed individual years of this ISS LIS, that is International Space Station LIS sensors. So from that, what I could understand is, see on this this LIS climatology, this this is Rajasthan actually. Sorry, this is Rajasthan actually. So on the western part, we have very less number of events. But when it comes to individual years, like in 2018 and 2019, we can see a very high accumulation of flash events, flash density events can be seen over here. That is something new. So when we look at this, is actually the rightmost figure is actually the lightning observation from ground that is taken from IITM. So they are also showing actually this blue and red are actually the amplitude. So when it comes to lightning, we have a negative amplitude lightning and a positive amplitude lightning. So basically it means when a negative amplitude is actually cloud to ground lightning, and a positive lightning is actually a ground to cloud movement of lightning. So obviously everywhere the cloud to ground is a normal thing, but for a ground to cloud lightning, such a severe scenario should be there, such a hot that much warm climate should be there for such an occurrences. So this shows that more positive amplitude lightning has been occurred over this western as well as in the central region of India, like in Rajasthan and Uttar Pradesh. We can see more red colored dots. That means more dangerous, more severe lightning flashes has been occurred over this year. And obviously from the IMD reports and the Crime Bureau reports, we can see in the central region of India, more deaths are occurred due to this lightning events as well. So that was the climatological analysis. Basically, we have to establish a ground-based observation system to understand this very frequent thunderstorm events. Then only we will have to take care of the fatality rate of thunderstorm events. So moving ahead, as I said, I've taken 3 case events over Jamshedpur. So this is the first case, which is a thunderstorm and gusty wind event. I've simulated this event using the WRF model, using initial data set of GFS, GRAS data set. So as you can see, the model could simulate it very precise note. As you can see, there was a 70 mm or more rainfall recorded, but as in the Jamshedpur, like in this red note, here it was around 28.6 mm rainfall was occurred. So almost accurate simulation was possible with the model. Also, you can see the gusty wind from these wind vectors as well. So here is 2 comparisons. One is IMD observation. This is IMD's reanalysis data set, which is a true data set, which IMD prepares using the merging of rain gauges and satellite data. On the other side, we have a ERA 5 reanalysis data set. So obviously there is a difference of what we say, a resolution, even though the ERA is not capable of representing this event, but IMD could do it better. And when we compare to IMD, model is also having a good simulation. So you can see from the wind vectors, a better simulation was possible. So briefly talking about the event was observed for a long time. So that is what I am interested of. Like when we have a longer event, the model is capable of detecting that, of simulating that. So it was a comparatively longer event of 8 hours from evening 3:30 to night 11 o'clock. And obviously WRF could simulate it very well. And yeah, when we talk about ERA 5 reanalysis data, it wasn't able to capture this event. And when we talk about the synoptic system, as in last presentations said, the anticyclonic and cyclonic circulation, which is used to occur over the northern part of Bay of Bengal, frequently carries these kinds of severe events to the eastern sides as well as the Bangladesh region. So, so what happens is when we talk about actually this was a detailed study. I haven't included an entire picture in this slide because of time. I will brief you about that. Like we have a like trough, we have a northern trough, usually used to see over the bottom of Himalaya, as well as when there is a cyclonic and anticyclonic circulations over the northern Bay of Bengal. Some these frontal events occurs, and that is why more number of severe like convective systems are happening on this eastern sides as well as in Bangladesh. So this was a comparison with the INSAT 3D observation. So as you can see, on right side we have INSAT 3D observation, on left side we have a model observation, I mean model output. So as you can see, it is also saying like the model could do a good simulation. Yeah, and the system movement is from the northern side. Okay, so this is a more detail. Like we have a geopotential, and we have a Cape study, and we have the wind gust as well. So coming to the geopotential on this on left side upper, you can see the 200. Yeah, you can see the 850 hbar lower geopotential range. So we can see a cyclonic circulation, which is marked as green shade. So we have a cyclonic circulation over there. When it comes to upper air, 200 hbar, a very fine dispersion can be seen over this region. So that's why, again, model could do a good job here. So when it comes to the wind gust, I've compared it with the ERA 5. So as you can see, ERA 5 could do it, but a delay in time. I mean, somewhere it shows at 6 UTC. It started and ended by 12 UTC. But when it comes to the model, as well as in observation, as I said, it was on evening 3:30. That is around this 12 UTC. That is around evening time. So model could do a good job in this simulating this case study. Another case was thundersquall and hailstorm. So this was a
Okay.
short
Can
event.
you finish
Yes,
it
sir.
by 1 minute?
Yeah. It's done, sir. Yeah. When it comes to squall and hailstorm, the hail part was not observed from the model, and you can see a squall is also available, and the bow-like structure is also simulated in the reflectivity. And the third part is lightning and thunderstorm and lightning. So this was also uh, barely simulated. And when we analyze the lightning part, you can see a positive lightning. We can see the positive lightning. So on this 31st of May 2019, there was a huge number of deaths reported um, this state. So basically, when I come to these statistics, we can say around 380 lives were lost in India in 2019, amongst 125 were in this particular state. So basically, this positive amplitude of lightning causes huge fatality rates with associated with these severe events. So I'm done with my presentation. I'm summarizing that inconsistency was found in the TRMM LIS climatology when it was compared with the Thyagis's thunderstorm frequency. Also, a very variations were like when we compare with the monthly climatologies, the variations were seen from the LIS to this Thyagis's climatology. And all three cases were unique in their appearances, but similar synoptic features was associated, like the cyclonic circulations and the trough passing was there in associated with these three events. Or the trough formation formed over Bihar region, along with the dry westerlies and the moist easterlies. Like we have a dry westerlies and suddenly a moist easterlies from the Bay of Bengal. So we have a frontal events over there. So key findings, when it comes to key findings on an annual basis, LIS observations can be used to understand and develop the climatology of thunderstorms on an annual basis only. So from the present LIS climatology, we can say around 10 times of flashes per 100 square kilometer can be equated to the thunderstorm frequency of that region. And obviously, there is the presence of easterlies was also noted. So thank you so much. This was from my side.
Thank you, Mr. Moses, for your nice presentation, and that was a very good simulation of the thunderstorms, and you have explained the climatology also. So I must thank you. Maybe I will ask only one question. Can anybody can ask a question? Anybody? One question?
Yes, sir.
Oh, Astaful perhaps, if I am not wrong.
Sorry, sir. I am Khan Mohammad Kalam Rabbani from Department
Rabbani,
of
yes.
Meteorology.
I'm sorry.
Sir, my question is to Musaid,
Yes,
PP.
Rabbani.
So you have compared model simulated reflectivity with inside 3D infrared brightness
Yeah.
temperature. So is it possible to compare infrared infrared brightness temperature with model simulated reflectivity? Is it really comparable? How does it actually conclude?
I mean, comparable in the sense of resolution?
No, actually, can you please show your slide from the reflectivity
Yeah, sure.
comparison? Here,
Yeah,
the
let me
left
see.
side image, as far I know, that this is model simulated reflectivity, which
Yeah.
gets data from radar observation, maybe in FNL or GFS data. But at the right side, you showed the thermal infrared from band 1. So is it really comparable? Because right side we see the cloud top brightness temperature. That is not also cloud top temperature, brightness temperature. So can we really compare these two images?
Basically, what I meant comparing this system, this images is to show the system occurrences.
Yes, maybe that.
Not the rate of reflectivity or not the not the temperature ratio, not to the variabilities.
Yes,
What I
yes.
meant was to show the capability of my model to get the system in it. So yeah, that's the only purpose I meant.
Okay, can I ask another question?
Yeah,
No,
sure,
no,
sure.
there is no time. I'm already
Okay.
behind the
Thank you, sir.
actual time.
Sir.
You can ask question in the chat box.
Yeah.
Okay, no problem. And now I wish to request my co-chair to conduct this session for the two other papers. May I request Engineer Vidyut Shaha to conduct this session? Hello? Hello? Do you hear me? And it is also, my net is also disturbing. Hello? Hello? Hello, do you hear me?
Yes,
Mr.
sir, we
Shah?
can hear you, sir.
I wish to request my co-chair to conduct the session for two other papers. Okay? Hello? I think Mr. Shah is also lost.
No, I am here.
Okay. Will you please conduct as the co-chair?
Yes, yes.
Okay,
Yes.
thank you. Thank you.
Sorry, please tell me again. I was
Oh, I requested you to conduct the session for two papers also, because you are my co-chair.
okay, no
So
problem.
you should also conduct. Okay,
Thank you,
very
sir.
much.
Thank you, sir, for giving me the opportunity to conduct the remaining two sessions. Now the time for Mr. Ashraful Islam is presenting the modeling of lightning events using WRF model study over Bangladesh. Thank you. You are requested to stick with time, okay?
Yeah.
Good morning. I am Ashraful Islam, MSc student, Department of Meteorology, University of Dhaka. My research title is Modeling of Lightning Events using Weather Research and Forecasting Model Derived Microphysical Parameters. Here is my research objective. First objective is find a legitimate relationship between lightning and cloud microphysical parameters. And second objective is correlation and regression analysis of individual selected cases and find out an estimate regression model. In my research, I used 5 types of data. First data is SQL data, which is collected from DMD. This data is used for case selection and to see the wind properties at lightning occurrence places. And second, I used the FNL 1 degree by 1 degree seasonally global data, which is used for WRF model run, and then WRF model output is used to find out the microphysical parameters. And ECM CF ERA 5 satellite data is used to compare the model output microphysical parameters and for model validation. And upper atmospheric sounding data, which is collected from University of Wyoming website, is used to check the instability situation of the atmosphere and also compare the WRF model drive stability diagram. ISS satellite-based flash count data is used to find out the correlation and regression analysis between lightning flash count and microphysical parameters.
Okay, you go on.
Meteorology. In this study, about 6 cases are selected. 2 cases is less severe, 2 cases moderate severe, and 2 cases is highly severe. 2 cases based on SQL data, select which data is collected from BMD, and other 4 cases is selected based on satellite lightning data. To investigate meteorological condition associated with lightning flash count rate from satellite LIS, ISS, microphysical parameters, and KF, and upper atmospheric condition of the atmosphere are analyzed in this research. Carl Pearson correlation of coefficient and an estimate regression model are analyzed between total lightning flash count and WRF model drive microphysical parameters using SPSS software, and my estimate regression model is here, and in this y is equal to dependent variables, and alpha, beta, gamma are the coefficient, and x1, x2, x3, x4 also is the independent variables. Is the brief description of my 6 selected cases. First cases is 24th March 2017. Here 2 cases is high severe, case 1 and case 4, and case 2 and case 5 is moderate severe, and case 3 and case 6 are less severe. Highly severe cases is occurrence of the Atpara Netrokona at 2247 UTC, and most severe on cases is case 4, 31 March 2019. Occurrence places is Purvadhola Netrokona, and occurrence time is 1747 UTC. Here the LI index and Cape value indicates that the most severe cases, case 1 and case 4, in LIS index is -5. That means the atmospheric condition is most unstable, and Cape value also indicates that the atmosphere is moderately unstable. Here is my model domain. First domain is my main domain, and second domain is nested domain. First domain resolution is 9 km, and second domain resolution is 3 km. This is my model description and physical option. I do not use the sensitivity test of WRF model. Only I use in this situation the physical option, which is the best output for model. Result and discussion. First case is 24th March 2017. I compared with the ice mixing ratio, snow mixing ratio, rainwater mixing ratio, cloud water mixing ratio with the satellite observation ERA5 data, and I compared at the same time to 22 UTC. In this situation and this time, model output and ERA observation data, ERA5 output data is really compared same places, and value are also always in this indicate that value are comparatively same here for first cases. And second case, first case Cape value model drive is here indicates that about 1022 kilojoule per kg, and study diagram indicates that Cape value temperature and the Cape value are always in this section is just always same. In second case, 23 April 2017, I compared with model drive microphysical parameters and ERA5 data. Here the occurrence places is Doloth Khan Upazila, Borishal. Here the ice mixing ratio also indicates the same places at same time, maximum, nearly maximum, and snow mixing ratio, rainwater mixing ratio, and cloud water mixing ratio are only all parameters are indicate the same region, but only cloud mixing ratio here indicates that some special deviation. And in this location, Cape value is high, about here the lipid index is -9. That is atmosphere is most unstable, and Cape value 300 150 joule per kg indicates that here the atmospheric condition was most unstable. In my third case, 29th April 2018, I compare with the model derived microphysical parameters with the ERA5 parameters. The occurrences places was Sherpur. In this situation, snow mixing ratio, ice mixing ratio, water mixing ratio is also indicates in this location maximum. Only the rainwater mixing ratio model derived is maximum in this case, but ERA 5 observation data is about in this situation is low. It is the Cape value of the model derived is indicates that the Cape was only 600 joule per kg, which is very low. That means in this location, atmosphere is moderately low, unstable, and SQT diagram indicates that here the unstable atmosphere is mostly unstable, and Cape value indicates that in this situation atmosphere is moderately unstable. Here is my Carl Pearson correlation of coefficient total light between total lighting flash count and microphysical parameters. In this case, total lighting flash count and microphysical parameters correlation with snow is 0.963 and significant value is 0.002. That means in this section, Q snow is highly significant, highly positive correlation with total lighting flash count, and Q graphel, Q cloud, Q vapor, Q rain is also high. All microphysical parameters are highly positive correlation with total lighting flash count. And regression analysis and my estimate regression model is here. In this case, the p-value indicates that the all microphysical parameters are highly significant for total lighting, are responsible for total lighting, lighting flash count. Discussion and conclusion in my research. Firstly, analysis the microphysical parameters derived model and ERA5 data have been concluded that there is a good associated with WRF model derived microphysical parameters and ERA5 data parameters. In my second discussion is this study found a high degree of positive correlation, which is range 0.87 to 0.97 between total lightning flash count and vertically integrated microphysical parameters, Q snow, Q cloud, ice, vapor, and rain graphel. And this study built an estimate regression model, which I show in before slide, model between total lighting flash count, which is dependent variable, and independent variables are Q snow, Q graphel, Q cloud, and Q vapor. Thank you, sir. If any question, then you can ask me.
Thank you, Mr. Ashrafur, for timely completion. I'd like to ask, invite question from the audience. If any questions, please ask. Any question, please?
One question from my side. Hello,
Okay, sir.
Ashraful.
Yes, sir.
How many data you have taken to find the correlation coefficient? Can you tell me? Number N. How many you have taken 4 or 5 cases, I think.
So about 6
So
cases.
what is it?
This, sir.
6 cases.
This, sir.
So 6 cases, I think if the number of data is less, then correlation coefficient may be higher. But if you take the data more than 30, practically, climatologically, it should be more than 30 or 30. Then if you get the correlation coefficient, that will be very more valid practically. Maybe
Yes,
in future you try. Okay.
okay, sir. Yes, sir.
Thank you. And 31, number 4 case. This is very important because on that day, perhaps one tornado occurred over Nepal, and there
Yes,
were, you know, 3 conjugation of easterly and westerly over West Bengal and western Bangladesh. That was a very important event for the thunderstorm. Thank you
yes, sir.
very much. Thank you very much.
Okay, thank you, sir.
Any more question? We can consider one more question. Any question from audience? No? Okay, then we go for the last resource person, the speaker, Mr. Kamrul Islam is ready. Mr. Kamrul Islam is ready. Mr. Kamrul Islam is presenting rainfall trends in northwestern part of Bangladesh.
Yes, sir.
Okay, start please.
Thank you for giving opportunity. I am Kamrul Islam Kurim. My research on analysis of rainfall trend in the northwestern part of Bangladesh. Research aim of my study is to investigate the trend and variability of rainfall throughout 1979 to 2019 years of the study area. The table represents the geographical location and the elevation of forestation of North Bengal. 41 years of rainfall data from 1979 to 2019 was collected from the Bangladesh Meteorological Department, and the map shows the position of 4 stations. I have followed this method to complete my research. Firstly, problem identification, literature review, study area selection, then research objectives, data collection, data processing, and data analysis, finding of the study, and conclusion. Simple linear regression to exhibit rainfall trend, and I have used data analyzed by using Microsoft Excel. Rainfall has increasing. In meteorological perspective, the season of Bangladesh can be divided into distinct seasons: pre-monsoon, monsoon, post-monsoon, and winter, respectively. March to May, June to September, October to November, December to February. Result and discussion of my study. Rainfall has an increasing trend both in pre-monsoon and post-monsoon, or 0.78 and 0.25 millimeter per year found respectively. In terms of pre-monsoon, average rainfall per year is higher than 300 millimeters, where the highest was around 600 millimeter in 1981 and lowest found in 1979, almost 100 millimeter, along with 120 millimeter in 1995. At the end of the period, consecutive 5 years from 2015, rainfall has an upward trend around 400 to 500 millimeter. In 1981 and 2011, almost no rainfall in the post-monsoon, while the highest rainfall was above 500 millimeter in 2005. There are fluctuations of rainfall throughout the period. Monsoon is considered the highest rainfall season, but the situation changes and it losses around 7.17 millimeter per year. Top rainfall happened in 1984, 1987, and 2019 around 1700 millimeter. Though in 2019 intense rainfall caused, in the last 10 years rainfall showed downward movement, where the lowest found in 2018 around 800 millimeter, which is the lowest in the last 40 years period. Winter can be divided into two periods, one from 1989 to 1999, where rainfall was greater than 20 millimeter, with highest rainfall in 1991 around 120 millimeter. The last 20 years of the rainfall in 2000, 2005, 2009, and 2017 experienced no rainfall. Bar diagram represent yearly average rainfall of 4 stations in Rangpur 2281 millimeter, Bogura 1715, Ishwati 1500, Rajshahi 1448 millimeter. Highest in Rangpur and lowest in Rajshahi. From line graph, rainfall decreases continuously if we move from northern to northwestern region. In Bogura, rainfall show a gentle trend in every 4 years. Rainfall balanced than the previous year, but the trend changed at the beginning of the 21st century. From 2010 to 2017, rainfall decreased a lot, and in 2017 it was 1100, which is the lowest and highest in 1998 around 2600 millimeter. The regular variation found in each showed the highest and lowest rainfall was around 2300 and 900 millimeter per year respectively. .34 and 7.93 millimeter rainfall decrease in Rajshahi and Rangpur. Also, the highest and lowest rainfall was 2200 and 800 millimeter in Rajshahi, and 3800 millimeter and 1300 millimeter in Rangpur respectively. The bar diagram represents the monthly average rainfall of 4 stations, where July is the month with the highest rainfall and January is the lowest around 366 and 8 millimeter per year respectively. Yearly average rainfall was almost 1715 millimeter. Combining all the 4 stations, decreasing rate of precipitation is 6.73 millimeter per year. Though highest rainfall found in 2019 around 2500 millimeter, in the last 10 years, rainfall decreased significantly. Finding of in my study, from 1979 to 2019, seasonally rainfall decreased around 1.61 millimeter per year, where in monsoon was highest almost 1.79 millimeter per year. Between those 4 stations, the highest rainfall was in Rangpur, 281 millimeter per year, and the lowest one found in Rajshahi, 1448 millimeter per year. All the stations had encountered less amount of rainfall, among them 9.43 millimeter per year rainfall lesson in Bogura, which is the highest amount of decreased rate of rainfall. 6.73 millimeter per year rainfall reduced combining all the stations. July is the highest rainfall month, where the lowest month is January, around 366 and 8 millimeter per year respectively. Assumption in my study, maybe in future, rainfall in pre-monsoon season continue the increasing trend, while in monsoon season intensity of rainfall exhibit the same downward trend. There is possibility that all the 4 regions face water shortage in future. Thank you. Any questions, sir?
Thank you, Mr. Kabir Islam, for your interesting presentation. From your research, we would be helped it would help us to realize the changing pattern of climate and its associated risk, and take preparation for the future events. Okay, I am asking questions from the audience, if any. Any question, please? No question, I think.
If there is no question, then I can ask one question, Mr. My co-chairman. Kamrul,
Yes, sir.
you have shown a very good trend of the rain that in 4 stations the rainfall is decreasing, but have you tested the significance of the decreasing trend? Because the R scale value shows that the values are very small, so maybe there is no significance of the trend. Have you tested?
Lightly it's changed, but not more. But northern portion of Bangladesh, i- last 10 years, rainfall has decreased more.
No, it is okay. It is okay. But have you tested the significance of the trend? No, perhaps no.
No,
Right?
no.
Okay. Okay. Thank you very much. Thank you.
Thank
Thank you.
you. This is my outcome of my assignment. Mainly, I'm in future is I will be studying that.
Okay. Okay.
Thank you.
Hope for the best.
Thank you. Okay, I would like to hand over to the chairperson for concluding.
Yeah, this is the concluding session. I think you are also in the session also as a co-chair. So actually we have very good presentations, 5 presentations. The first one started by Mr. Kamrul Hassan. He is a very good meteorologist, and actually he's looking after the technical side of the models and everything. And he tried to compare the two. He did not compare the two methods. Practically, the Dubey method or IIT method is also good in predicting the but now I think MRI method has given also very good. But the problem is that the validation of the result is not possible because of the coastal region, but there is no other stations along the coast. So that is a problem for us. And the MRI, I think it is good, but I think Kamrul model has given a little bit higher values, 3.5, something like that. I think it is less. The Amphan storm surge was around 15 to 18 feet or less than 3.5 meter. This is my experience, what I have seen at the time. So, but his presentation, his results were very attractive. I must thank Mr. Kamrul Hassan for his nice presentation. Then the second paper was made by the Dr. Nazmul. He is a very good modeler also, and also very experienced scientist in the simulation of heavy rainfall. And that rainfall practically 26, 27 September, I think that was very important, and I think that caused a flash flood or flood over the rivers Jamuna, Ghagot, Dharala, and also Dutkumar. So that was very important to simulate, and he has simulated this one. And rainfall was, practically 449 in 24 hours, and only 12 hours there was 443 millimeter rainfall from, I think, 12 or 16 UTC to 4 UTC of the next day. So that was very important. And this year, practically 4 to 5 times flood occurred, and my co-chair will be able to tell about this number of floods because he's from that department. But I have seen
Yes.
from the TV that 4 or 5 times floods occurred in the northwestern region because of the heavy rainfall there. So
Yes.
that is also very good presentation. And understanding the thunderstorm frequency in India, Mr. Muse, he also gave a very good presentation on the climatology of thunderstorms. I must thank him, and maybe we met in the university, Central University of Rajasthan last year. I think so. I met him there. And I must thank him for his nice presentation and about the lightning events using weather research and forecasting method model derived microphysical parameters by Mr. Asraful Islam. Uh, his case 4 already I mentioned that was very severe thunderstorms, and I think unparalleled thunderstorm. His presentation and modeling, I think that was very nice. And the last one already, he is a very new man in the area in this area. He analyzed rainfall and showed that the rainfall is happening in the western or northwestern side of our country, and this is not a good sign for the agricultural activities in our country. But he maybe encouraged to 5 presenters now or request my co-chair to say something. My co-chair, Mr. Shah.
Thank you. Thank you, sir. I am very much delighted for inviting me as co-chair of this technical session. I am especially thanks to the organizer of this international conference. Also, I want to mention the name of Mr. Shubho. He always contact with me regarding this session, this conference, and still is contacting me. And I actually, this is a very interesting seminar, international seminar conference for me also, because this seminar is related with this my organization, Water Development Board. There's my office is forecasting flood forecasting the whole year. They are only organization for the national forecasting from Water Development Board for flood only. And the papers presented here is very interesting for me, because this Amphan cyclone, storm surge is very interesting. But Water Board has no scope of forecasting for storm surge yet. I think this type of model development will be very helpful for our coastal belt region, especially where the storm surge affected and loss of lives. And also there are rainfall events over Rangpur. This article is also interesting. And yes, my chair also mentioned this year a flood occurs 4 or 5 times. That was unusual, actually. So in a localized area, if a heavy rainfall occurred for a short duration, it always creates a flash flood and water congestion in that area. And so, lightning and thunderstorm is very interesting for me also. And also, you know, the a lot of lives lost during this thunderstorm and lightning period, and therefore the government declared, our Bangladesh government declared this is also a disaster. Finally, I hope this it is a very good opportunity for us to learn from this international conference, and I wish a very good conclusion, good closing of this conference. Thank you all. Over to Chairman. I think Chairman can say and conclude the session. Thank you all the participants, presenter, for nice presentation. I'd like to hand over to Dr. Shamarendra Karmakar, the chairperson.
I'm sorry.
I would like to hand over to you, Chair, for concluding the session.
Yeah, thank you very much. Now I see a very
Sorry.
Prabhat Kumar, how are you? But these two pages, I think 2 pages of the two eminent scientists, but at the last moment. So thank you very much for your presence.
Fine, fine. Thank you. Thank you so much. Are you getting my audio?
Prabhat Kumar, how are you?
Yeah, fine. I'm fine.
Close this
Getting my audio
earlier because we have. So if there.
Hello.
Hello.
Yes, yes.
Do you hear me?
Yes, I can listen you.
Yeah. So I must thank all of the audience and the presenters for their passion sharing and also for the nice questions raised by some audiences and the presenters, 5 presenters, out of which 2 or 3 are very new, 2 or 3 are, very eminent also. So I must thank all of them. So I am going to close this session now. Thank you very much. And before this, I also must thank the organizer for such an international conference on meteorology and climate science in Bangladesh. Thank you very much. Bye.
Thank you.
On behalf of the organizing committee of this conference, and Department of Meteorology, I would like to thank Honorable Chair and Co-Chair for conducting the session and all the presenters for their wonderful presentation. I would also like to thank all the audience for being present in this session. The next session of the conference will be start at 12 in Bangladesh Standard Time. So all are invited to join the session. Thank you all.
Okay, Saurabh, thank you. Thank you very much.
Thank you, sir.